Okay, so before we start, let me introduce ourselves a bit. My name is Giang. You can call me Giang or Lucas. I'm from FPT Software, and we are doing providing the security services all over the world. And together with me today, we have Tung, my colleague, and he will talk more about the AI stuff. And I will do the some introduction first. And I think you guys already know about Sigma rule, but for some online guys here, they may not know about this one first. So Sigma rule is a rule-based detection format, and it's designed for some kind of CM and EDR platform, and its focus is on the log-based detection across multiple environments like Windows, Linux, and cloud, etc. And Sigma rule is familiar with blue teams and also sub teams because of its advantages, like it can be converted into different CM format, like Splunk, we have Microsoft Sentinel or Elasticsearch. And it's also using the YAML format, so it will have a human readable and flexible in the format. And last but not least, it is an open source standard, and we have a like huge community for the Sigma rule. Okay, so what is the problem with Sigma rule? So as I said, we are providing the service, especially for the sub-service for multiple customers. So that's why we need to deploy a lot of detection rules, and we need to keep them updated. And as you know, the threat is increasing day by day, and our security analyst team, especially for the detection engineer, a junior, they would need 3 working days to process a security blocks, and their output is around 20 Sigma rules for each block, and it's like take a lot of time, take a lot of effort to doing it manually. And I do have an idea on like, can we automate the process to generate it more automatically, or can we leverage AI, the power of AI to do that more quicker? But we face some problem, some challenges. So the first, the AI can actually speed up the rule generation, but it like incorrect with the MITRE ATT&CK mapping, and the syntax, also about the logic mistake. And the last thing is high false positive and low reliability. Not only about the error in logic, but also about the time we need to spend to validate that rule, because after generate that, we need more effort to validate the output. That is our challenge. And here is an example of current LLM. We use the model like a really small one, GPT-4o mini. In 2024, we have the system Pham here. It's a bit small, right? But something like you are an expert in Sigma generation, and you follow the Sigma schema, and then the user prompt will include, this one is a security block. We extracted from a block, and then we map it with MITRE ATT&CK technique with this block. And then you can see the output here with a lot of errors in, especially the logic is too generic, and also some syntax error like incorrect log source, incorrect references, and incorrect tags. It is like not acceptable output. So we comes up with a SigmaGen. It's a combine of Sigma and generation. That's it. And with the SigmaGen, the input will be some security blocks or any campaign we have. And then we map it, we extract the content, we map it with the MITRE ATT&CK technique. And then it will go through our fine-tuned LLM. So the output will be higher in accuracy. Okay, so we go to the high-level design here. It's kind of basic with the idea. First, we have the threat and vulnerability news or blocks. Then we extract that. And third one, we'll map it with MITRE ATT&CK. And then we will go through our fine-tuned LLM, and the output will be the detection Sigma rules. And how about our fine-tuned LLM? We have Sigma repo, and we extract around 200 blocks and 200 and map it with around 200 rules. And we have a data set, and then fine-tune it, and we have our fine-tune model here. And in the next slide, we will talk a bit more about how we fine-tune and how we leverage AI into the SigmaGen. So please, Tung, we'll continue the presentation.
Okay, thanks, Giang. Thanks for the overview of why are we doing this, right? So now we have the input, right? It's the thread block and the thread blocks. Right? So and the output we want is the unusable, unactionable Sigma rules that we can convert it into another SIAM, another EDR. So first, we just use the AI to like read the block, and then use some prompt engineering to fine-tune the to generate the detection rule. But that approach is not working, right? So we comes up with another like a bridge between the block itself and the rules, right? That is mapping the block content using AI, using LLM to the MITRE ATT&CK techniques. So when we come to this, well, we come to another issue, how we map it into the MITRE ATT&CK techniques. So we found an open source solution, right? It's using the threat report attack mapper, Pham for short. So this project is open source, and it has been in the internet for like 3-4 years now. And the issue with this project, so we use this, and it generates the attack techniques, but it's not quite correct. So the effectiveness is like 40%, right? Only 40% correct between like human mapper. So we have to retrain this model. Is that the first thing we do? And well, fortunately for us, we found a data set with updated data on the MITRE techniques. So that is just a win-win. So we use it, we train it, and the accuracy goes up from there. It's like, so from we testing, we have not have a huge GPU powered machine. So we just train it with very minor prompts. So it's just like up in about 60%, 60 to 70%. Okay. So back to the main part, right? We have this cover. So how do we fine-tune the LM to actually run it with all those data? Okay, here's how we do it. So first of all, we using the Sigma report, right? With the Sigma report, we extracted it contents, we extracted it, and then we put it in this 3-part prompts. So first part is just the same as before. The prompt engineer is like role playing a little bit, assign the roles to the bot with some Sigma specification. So this is important because it's the bot will know what to check for when it generates the rules. The second part, so in the Sigma rule itself, it will help the reference and the MITRE ATT&CK technique, assign it with using attack, and we come back to the bot here, right? So we use the exact same process here to extract the block content, and we already have the MITRE ATT&CK technique, and we put it into the user prompt. The assistant output is the Sigma rules that we want, right? So we're using that data set. We built like 1,000 prompts, but we only use 200 here because there's some issue with the Azure AI as we are using. Okay. So the result, we can see here is the result is much, much better. So the same old GPT-4o mini with some fine tuning, right? The system prompt is exactly the same. The user prompt is exactly the same block, same technique as before. And you can see the result is much, much better. The logic is clear. That is NG-rock here, this case. And the command line is also correct. And everything else, it looks like a human rules. Okay, so this is the last part. So I want to have a little bit of cost breakdown because well, not everyone have the GPU to run this locally, right? So we just use a very, very small model, GPT-4o mini, which is very small, very cheap, using the Azure AI. And for the training cost, so this is one of time only, which is we calculate is around 96,000 token per prompt, which is when we train it 200 prompts, it's $64. This is US dollar, so not Singapore dollars. The total data set, if we use 1,000 prompts, it's like 320. So the cost to run it. So after this one-off payment, the cost to run it, let's say we run it every week for will be on the system will be online for 4 hours only because this is run like 10 minutes and it will run into one block. So over 4 weeks, months, right? So the cost is only $29 per month, which is very cheap in my opinion. And the per year is like 350 in cybersecurity and in cybersecurity products. This is nothing, right? This is just very, very cheap. Okay. So here's our key takeaways for you guys. So use AI power Sigma rule to save times. The accuracy is really matter. So even with the fine-tune AI is still gonna require some testing and some validate, but this is just much better. And just continue rules update, keeping up with the trends every week. And this is like the first part, right? Generate the Sigma rule, which is the first part. And this in the future, right? Fully automated detection and deployment. That is what we aim for. But this is like the very, very first step. And if you want more details or if you want access to the dataset that we use, please you follow this QR. So we will release the dataset after the community workshop. And that is all for me. So thank you. Yeah.